Chapter 4, Materials, Metals and Non-Metals. Part 1, Introduction. In this chapter, we'll see that we have already familiar with the number of materials like iron, aluminum, copper, etc. As the materials you can see around us, and there are various kind of the materials we are using in our day-to-day life. Some materials as appearance have shiny or dull. That you have already seen this kind of steel material, it is little bit shiny, and some irons are little bit dull, which is color in the black. Some materials are hard and some are soft in nature, that also you have feel and experience in your day-to-day life. Some materials have been given in table 4.1, which is in your book, that you have to fill like this, like object and materials like iron, coal, sulfur, aluminum, copper. These are the different kind of the materials, metals and non-metals, and what are the shapes, then hardness and materials that you have to fill up. Let's continue. So the rest of the materials in table 4.1 are the non-matter. As you can see in the previous table, some materials are non-matter, like sulfur is a non-matter. So metals can be distinguished from non-metals on the basis of their physical and chemical properties. Now, in this chapter, mostly we understood with the different kind of the activities like physical and chemical. So physical, we know that when we touch the some material like any iron or aluminum, so this is called physical properties. And chemical, that means we have to do some reaction and action with some different kind of the liquids that we'll see in this chapter ahead. So recall the luster and the hardness are physical properties, as you have already learned in the lower classes. Physical properties of the metals and non-metals. Now the chapter is basically start from here. Have you ever seen a blacksmith beating an iron piece or an article made of iron like a spade or shovel and axe? Have you ever seen that? Yeah, you might have seen, not maybe physical, but maybe in some movies or maybe in some serials that you have already seen. So do you find a change in the shape of this article on the beating? Of course, yes. Because when the iron is little bit hot or warm, when we are completely beating on that, it will automatically shape the, not automatically, but after beating, it will shape the change. Okay. Would you accept a similar change if we try to beat a wood log? Of course not, because after beating the wood log, it won't change the shape, but it will be little bit make into the 2-3 different parts, because this is the soft property, soft material. You show the shape of the iron nails and the aluminum wire change on beating, as you have already seen, like our copper wire which we are using in the electricity, that also after beating it, it can be flat. And they were beaten harder, this could be changed into this sheet. That means from the metal or from the any kind of metallic material, that metal can be converted into the sheet, like aluminum sheet, metal sheet that you have also seen in your home. You might be familiar with the silver foil used for the decorating sweet, and you must be familiar with the aluminum foil used for the wrapping food. So the properties of the metals by which they can be beaten into thin sheet is called metability. So here we have to understand what is called metability. That means after beating the some specific material and it can convert into the sheet metal, that is called a metability. This is a characteristics properties of a metal. As you must have noticed, materials like coal and pencil lead do not show this property because these are not called metals. Okay, because when we beat or when we heat that, what will happen? It will be dispersed and it will be made into the powder form. It will not convert it into the sheet form. Correct? So it has no metability of the materials like coal and pencil. Can we call these metals? Of course not. Correct? This kind of materials like coal and pencil, we do not call it a metal. So as you know, metals are good conductors of heat. and electricity. As you have already seen and maybe you have felt that also. If you are using some wood material, when the electricity is passing, you won't get any kind of current or shock. But if the current is passing and suppose if you touch with any kind of metallic material, you will get the shock because the metals are good conductors of heat and electricity. So where do you find the use of aluminum and copper wires? Have you seen the wires of coal? Of course not. Clear? So we can see the different kind of the wires like aluminum wires, copper wires. Clear? So these are the different wires which we are using in our home or overhead wires which are there in our outside of the areas. Outside of the areas wires basically made with the aluminum. Okay. So the conductivity of the electricity is also based on the different kind of the metals that we'll study in the higher classes, that we are not going to discuss over here. Here we have to discuss only with the aluminum and copper wires is the good conductor of the electricity. So the properties of metal by which it can be drawn into wires are called ductility. So what is called ductility? The properties of metal which can be drawn into wires. That means any material can convert it into the wire just like a metal is called the ductility. That depends on the material to material differ. So very good ductility of the one metal is called gold. Gold is also one kind of the metal, but it is a precious metal and it is also a good conductor of the electricity. But due to this precious gold and silver, we are not using to make a wire. Okay, so this is just for your knowledge. Gold is also a good conductor and which is the very high ductility in the metal. Have you ever noticed the difference in the sound on dropping an iron sheet plate, a metal coin and a piece of the coal on the floor? Of course, you might have feel the experience also. When you just toss the coin, what will happen? It will come with the different sound because the metal sound is different and the coal sound is also different because the metal is little bit hard and coal is little bit soft. There is one more thing. Have you seen wooden bells in the temples? Of course not. Can you give a reason? Yes, because when we hit the wood, what will happen? It will not produce a sound. Correct? It will not produce a good sound. So the things made of metal produce a ringing sound when they struck hard. That means all the metals normally made a ringing sound. In normal, we are using the steel sound. In your home also you can do some experience when you are beating a spoon with the disc, steel disc. It will make a different sound. When you are beating the spoon with the different metallic sheet, it will coming with the different sound. So these are the different sounds are coming from the different metallic materials also. Suppose you have two boxes similar in the appearance, one made of wood and other of the metal. So which one get the more sound? Of course metal. Metal will get the more sound of that. So since the metal produce ringing sound, they are said to be sonorous. That means here we have to understand the word that is called sonorous. Sonorous will basically produce a ringing sound in the metal. And the materials other than metals are not sonorous. Okay? Like wood, coal, these are not sonorous sound. These are not the ringing sound. Okay? After performing the above activities, we'll see that we can say that some materials are hard, lustrous, malleable, ductile, sonorous, and good conductors of the heat and electricity. I hope you understand in this basic topics of the metals and non-metals. In the next slide and in the next part, we will see the different activities on the chemical based properties, how it can be differ from metal and non-metal. Some materials which generally possess these properties are called metals. That means those materials who have hard, lustrous, malleability, ductility, sonorous, and the good conductor of the heat and electricity are called the metals. These properties have all these properties in one kind of the things. These materials are called metals. And the examples of the metals are iron, copper, aluminium, calcium, magnesium, etc. There are various examples are there, but in your book some only examples are given over here. In contrast, materials like gold and sulfur are soft and dull in appearance. They are not a shining material. So they break down into powdery mash on tapping with the hammer. As I have already told you earlier in this slide, that when we are hammering and when we are just beating with this kind of material like sulfur or the coal, it will not convert it into the sheet metal, but it will come into the powdery form, or it will be breakdown. Clear? Okay, so they are not sonorous, so it won't produce a good sound, and they are also a poor conductor of heat and electricity. So these materials are called non-metals. The non-metals examples we have already seen. So the examples are that sulfur, carbon, oxygen, phosphorus, etc. Like metal, metals like sodium and potassium are soft and can be cut with a knife. That means some metals are that much of soft we can easily cut with a knife. Clear? So mercury is only the metal which is found in liquid. So this point I have just make it in the different color, because this you have to understand. Normally mercury is come in the liquid form, but this is not a liquid. It is comes in the form, and the state of the room temperature, these are exceptions. So this is only the material which is mercury is called a metal which form in the liquid. So this point you have to remember. It will be useful for the future. Chemical properties of metals and non-metals. First, we'll do the activities with the reaction with oxygen. As you know that some materials are rusted after some time. Like if you put some metals, or if you put some nails or any kind of bikes or cycles after long period of in the like open air, what will happen? After 6 months or 1 year, what will happen? It will started rusting, because it is with the contact in the oxygen. Clear? So that we'll see over here. So you are familiar with the phenomenon of the rusting of the iron that I have already told you right now. So recall the reaction by which rust is formed. You had also performed in class 7, I think so. So an activity burning a magnesium ribbon in the air. Okay? If you did this practical, you might have come to know that if a magnesium ribbon in the air, it will come with the different color and the different form. So you also had learned in the both processes oxide formation take places. So complete the following reaction of the iron and the magnesium with the oxygen. This can be happened, and this can be done only in the practical. Here it cannot be explained very nicely. So if we have chance, then I will also show you in the practical lab. Clear? For example, iron is the chemical form is Fe plus oxygen O2 plus water H2O. What will it form? So iron, oxygen and water, when we combine it, it will, what will happen? Same like that magnesium, that is Mg, and oxygen, what will it form? These are the basic reaction. Iron is comes into the contact with the oxygen and water. It will start rusting. Magnesium and oxygen, it will start flaming. Clear? I hope you understand this topic. Some parts